Welcome to a lesson with Dr. Powell. Let's take a look at how we can think about the chain rule backwards as we're taking antiderivatives. First, let's look at what the chain rule does. First, we take a derivative with respect to some chunk, u. So I'm letting u refer to the chunk that we have. For instance, if we had something like cosine of 2x perhaps, then if we let this guy right here be, we could let that be equal to u. So in taking the derivative, what would happen? Well, first we take the derivative of cosine of chunk, or cosine of u rather, which is negative sine of chunk or sine of u, say. Then the next part is to multiply by the derivative of u, which in this case would be 2. So that the derivative would be negative sine of 2x multiplied by 2. Now, if we were to work backwards, what would happen? The first step is to divide by the derivative of u. So the derivative of u, which is chosen, which is 2x, we divide by. And then we take an antiderivative with respect to u. So now this looks like negative sine of u. And the antiderivative of negative sine of u is just cosine of u, when we can replace the 2x back. So cosine of 2x as desired. So the antiderivative of negative sine of 2x times 2 ends up being cosine 2x. And what we did is we basically just did the chain rule completely backwards. Now, what if this guy is the derivative of u is in a constant? Let's see kind of how we can work with that a little bit. Here's an example. What if we want to find the antiderivative of sine x times cosine x, the general antiderivative, so the indefinite integral, say? Well, first let's choose a chunk. We choose a chunk in such a way such that when we start off by dividing by the derivative of it, things look nicer. So one way of conducting that first step, looking forward to the second step, is to replace this dx, which means take an antiderivative with respect to x, replace it with du. So we know that we're going to be taking an antiderivative with respect to u. But before we take that antiderivative, we're going to have to be dividing by the derivative of u itself. So doing that, just replacing dx with du over cosine x takes care of that first step, where we divide by the derivative of u, and it prepares us to be able to take the antiderivative with respect to u. So then notice what happens. These cosines cancel. So then we have the integral of, and sine x is just u, the integral of u du here. So we're just taking the antiderivative of u, which is u squared over 2 plus some constant c. This is going to be equal to sine squared of x over 2 plus c. That's because u is equal to sine x. So we just successfully used U substitution, which is just backwards chain rule, replacing dx with du over the derivative of u, where we just pick something in here to be u, and going through that process and arriving at our antiderivative. Thanks for watching.